We shall start with the first problem for Hebbian learning rule. The first problem says, implement the Hebbian training rule for a network using f of net is equal to sine of net. The three input vectors for training and the initial weight vector is given as follows. So you can see a set of four vectors which is given here in this problem. You have to use the Hebbian learning rule. And also it is, as we know that Hebbian learning rule is can be used either for binary neuron or continuous neuron, discrete as well as continuous neuron it can be used for. So as of now what we are given is we are given f of net is equal to sine of. Now when I say f of net is equal to sine of net, it is nothing but it is a bipolar binary neuron. It is a bipolar binary neuron. So you already know when I say f of net is equal to sine of net, what does it mean? F of net is equal to 1 for net is greater than or equal to 0, and f of net is equal to minus 1 for net is less than 0. This is the specification. Now you can use it also for unipolar binary neuron or unipolar continuous neuron or bipolar continuous neuron. So the equations will change. Now what is given here is that three input vectors are given. So when three input vectors are given, this is x1, x2 and x3. These are the three input vectors which are given. Each of these has got four inputs. So when I mean to say four inputs, it will be somewhat like this: x1, there are 4 units. So this particular neuron will have 4 units. There are 4 inputs. We have seen that there are 3 training vectors which are given, x1, x2 and x3. Now each of these have got how many inputs? It is a vector, so it has got 4 inputs in each of these particular input vector. So whenever I have a neuron, I can just model the neuron like this. There is x1, x2, x3 and x4. And we have these weights. Some initial weights are there and this is the output. So what are these initial weights? The initial weight vector is given here. This is the weight vector which is the initial weight vector. So the first one is 1, that is this one. Second one is minus 1, that is this one. Third one is 0 and fourth one is 0.5. Now what do we have to do in this particular, this is data which is given as of now. First, we have to present the first input, that is this one. So, I am giving at the input 1, minus 2, 1.5 and 0. And after doing this, I calculate what is net. And after finding net, I calculate what is f of net. Now, after doing this, according to the Hebbian learning rule, we have to check whether f of net is equal to plus 1 or f of net is equal to minus 1, because f of net is given as sine of net. So we have to check whether f of net is plus 1 or minus 1, and accordingly we have to do something called as weight update. Now what is this equation for weight update? We have calculate the delta W. And how is this delta W calculated in Hebbian learning rule? Okay, what is delta W? Delta W is C f of net into x. So this is what we will be using, C into f of net into x. Now, based upon this, we have to calculate the, we have to calculate W2, that is the weight W2. This weight we have to calculate. Now what is this? The delta W plus W1. That is the initial weight vector plus the weight update. So this is what we have to, this is the way we have to solve this particular problem. So how we would be doing this? This is just a brief, I have briefed you all about, what is the first step. I'll repeat. First, you present this first input pattern x1 to this particular network and we calculate this delta W. And after calculating delta W, we get W2, that is delta W plus W1. After that, you present the second pattern, that is x2, and then again you calculate delta W. And then you will get W3, which is equal to delta W plus W2. This is already there. So similarly, you present x3 and so on and so forth. So this is the way you have to solve the problem. So we shall do step by step the problem. Now iteration 1, step 1. What is the first step? First step is present. Now iteration 1, step 1. What is the first step? First step is to present the pattern. You have to present pattern vector or the input vector x1. And whenever you present the input pattern x1, we have to calculate net 1. So what is x1? As it is already given to you, x1 is 1 minus 2, 1.50. So when you present this particular pattern, we have to calculate net 1. So what is net 1? As you know, it is W1 x1 plus W2 x2 plus W3 x3 plus W4 x4. So how to calculate this? The formula of net 1, we will be writing it as it is W1 transpose into x1. So we take the transpose of W1, 1 minus 1, 0.5, and you multiply with x1. So x1 is 1 minus 2, 1.50. Whenever you do this, you will get the answer. You can find out what is the answer. 1 plus 2. So answer will be 3. Net will be equal to 3. After doing this, we have to find f of net 1. What is this f of net 1? It is sine of net 1. So when I mean to say sine of net 1, it only means what is the sine of this particular number. It is as simple. If at all this number is positive, then the answer is 1. If at all the answer is negative, if at all the sine of net 1 is negative, then f of net 1 is equal to minus 1. After calculating this, what we have to find out is we have to find out delta W. And what is this delta W? C into f net 1 into x1. Now please see, although it's not given in this particular problem, but you can assume C is equal to 1. So whenever C is not given, you assume C is equal to 1. So C is assumed to be equal to 1 and it is 1. And f of net is also 1 and x1 is this particular weight vector 1 minus 2, 1.50. Now what is left is that you have to find out what is delta W, what is W2. So what is W2? I shall just do it here itself. W2 will be nothing but delta W1, this is delta W1 plus this. So what would you get is, this is same 1 minus 2, 1.5, 0 plus 1 minus 1, 0.5. So the answer of this would be 2 minus 3, 1.5, 0.5. So this you get is W2. So this is the weight. Now this weight you have to use for the next iteration. Is that clear? So we go to the next iteration. We proceed with step 2, iteration 1, step 2. In this case, we present input vector x2. And what is this input vector? Okay, we start with step 2. Next step is step 2. We present input vector x2. And what is the input vector x2? 1 minus 0.5 minus 2, 1.5. So when we present this particular vector, we have to calculate net 2. What is net 2? So net 2 is nothing but W2 transpose into x2. So when I take W2 transpose, it will be 2 minus 3, 1.5 and 0.5, and it will be x2, that is this. And whenever we find this 1 minus 0.5 minus 2 minus 1.5, if at all you solve this, you will get the answer. Please find out this answer. I want you to solve along with me so that you can check the answer at the same time. You should solve and you should check the answer. Okay, if at all you find out, you will get it as minus 0.5. So when you get this as minus 0.5, what will be Fnet 2? Fnet 2 will be equal to minus 1, because you know that net is a negative value. So based upon that, we have calculate the weight delta W2, and also we have to calculate W3, that is the weight W3. So I shall directly calculate W3, which is same as delta W2, and if you can calculate delta W2 separately also, plus W2. So if at all you want to calculate it separately, delta W2, how you would do it? Delta W2 is nothing but C, which is 1, and then F of net 2, which is minus 1, into the input pattern 1 minus 0.5 minus 2 minus 1.5. So this is what you do, and delta W2 will become what? Minus 1 plus 0.5, 2, 1.5 plus 2 minus 3, 1.5 and 0.5. So what is the value of this? So you get this particular value of W3. That is, the weight is getting updated every now and then. So next we have to present pattern X3, that is this one, and recalculate the weight. So if not, you see what we are doing at every step, we are presenting a pattern X1 and calculating the weight again. So initially the weight vector given is W1. So when you present the first pattern, you get W2. Then you present the second pattern, you get W3. And when you present the third pattern, you will get W4. Now you are given only 3 patterns. Does that mean that the work ends here only? No. What happens is that, now here I have considered iteration 1 step 2. Now what will be iteration 1 step 3? Iteration 1 step 3 will be when you present X3. Now you have only 3 training vectors which are given to you. But it doesn't mean that you will train it only once. After X3 is over, then we come back to X1 and train it again with X1, X2, X3, and that is the time it is called as iteration 2. So usually in artificial neural networks, whatever problems are given to you in class, definitely we are going to solve only iteration 1 or iteration 2, maximum iteration 2. Even in the exam, it will be iteration 1 or iteration 2, not more than that. But in the real life, if at all you are using, say, some neural networks, you will not be able to use only 1 or 2 iterations, because there is no much learning which takes place. You have to train the network again and again. Also, here there are only 3 training patterns which are given. In real life, it won't be only 3 training patterns which will be given. There will be more than that patterns which will be presented. So that's the reason, so that the neural network learns. Now in this case, the neural network may not learn that much. So what we have to do is that in the problems, whatever we are given to you to be solved in the exam, you have to stop maybe at iteration 1 or iteration 2. Hebbian learning rule, it is a very simple learning rule. You could be expected to, find, say, 2 iterations. 2 iterations meaning 3 patterns are given, meaning the same procedure you have to do 6 times. If all you are given 1 iteration only, then only 3 times you have to do. Now we have already done 2 times, iteration 1 step 1, iteration 1 step 2. Now we shall move forward to iteration 1 step 3. Next step, you present in this iteration 1 step 3, you will be presenting input vector x3, and input vector x3 is 0, 1, minus 1, 1.5. So when you present it, what is the weight transpose? This is the weight vector which is already given. So you have to take the transpose of it, and then you have to take this one, that is multiplied by this one, 0, 1, minus 1, 1.5. You can calculate what is the value of net. This is net 3, and based upon that you have to calculate the value of f net 3. And after that you have to find out W4, which is nothing but, before that you have to find out delta W3, which will be C f of net 3 into x3. So, and after that W4 will be delta W3 plus W3. Now on the textbook, this W raised to 3 they write, W raised to 4 they write. If at all you want it as a superscript, you can write it as a superscript. I do not have any problem. So this, while writing this 1 here, you can write a 1 here. It's not a big thing. Okay. So I wanted to complete this particular problem. I am stopping till here. This is iteration 1 step 3. I want you all to do iteration 2 step 1, iteration 2 step 2, iteration 2 step 3. So after this wait, so last answer, here we will be getting W4. Then we will get W5, W6, W7. So you will be getting all these 3 up till W7. So although it is a bit lengthy procedure, but this is it's not something great. Just you have to use the formula and then get it. Is that clear? We'll move on to the second problem. It is the same problem, but only with certain changes. This is the second problem. But what are the changes? We shall see here. It is given bipolar continuous activation function. So bipolar continuous activation function meaning f of net is equal to 1 minus exponential minus lambda net upon 1 plus exponential of minus lambda net. But it is told to you that C is equal to 1, lambda is equal to 1. So here this lambda will be equal to 1. The rest everything remains the same. So what you have to do is that the similar way you have to, the procedure is the same. Iteration 1, step 1. What is the step 1? Present pattern x1. So you present pattern x1. So when you present pattern x1, you will get the same. What is net 1? Net 1 is the same what you have calculated in the previous problem. Please remember, only for first step the net 1 would be the same. Next step it may not be the same. So don't make this mistake. Calculate it again. Net 1 is equal to what? W1 transpose into x1, and that is the same here. 1 minus 1, 0.5, and into it is 1 minus 2, 1.5, 0. When you get this, answer is 3. So what is f of net? Here f of net is different. So what you have to do is that f of net 1 is equal to, you have to use this formula, 1 minus exponential of minus 3 upon 1 plus exponential of minus 3. You have to find out this particular value. Please find out this value. The value which we get is 0.905. Now based upon this particular value, f of net, we have to find now what? We have to find delta W1, which is nothing but C into f of net 1 into x1. So C is 1, so it will be 0.905 into x1, that is your input pattern. And once you get this, what will be W2? W2 will be delta W1 plus W1. So here in this particular problem, I am using all subscript only. If at all you want, you can use subscript, or you can use superscript. That is your choice. I prefer using subscript. So you have to find this W2. After finding W2, you have to present pattern X2, then present pattern X3, and then find out what are the answers. Is that clear? So the answers of this I would be presenting maybe next time, so that after you solve this particular problem, you can check for the answers of this one. Is that clear? So I want you all to solve this particular problem, solve the previous problem on Hebbian learning rule.